Alright guys, so welcome to week 3, checkpoint 1. I decided to go ahead and create a little tutorial video on a example that's very similar to your assignment. It's not your assignment, but it has all the elements that are required of your assignment. So I just want to quickly kind of walk through what's required for this checkpoint, and then kind of go over an example that's very similar, and I'll show you in a Word document what I'm expecting to see when I'm grading this assignment. Okay, so let's just look real quick at your syllabus for this checkpoint. It's outlined right here. I've got it up for the week 3. Our checkpoint is sequential and selection, processing, control structures. So basically, this assignment's only going to use two of your control structures that you've learned about over the past few weeks, and that's sequential and selection. You won't see any iterative control structures used in this assignment, but that's later in the class. So they want you to basically implement this following scenario. They want you to be an accountant setting up a payroll system. They want you to be able to enter in basically the employee's salary, and then using Appendix G. Appendix G in this case is kind of your requirements for this program. So let me go ahead and pull that up for you real quick. It wants you to take a look at the salary that's entered, and these are your requirements. So if your salary is between $0 and $1,500, your base tax, which is basically the amount you owe no matter what, if it's between $0 and $1,500 is $0, and this percentage of excess, this 15% here, is basically applied to any money that's in excess of the minimum value. So let's say you made $1,000, right? Your base tax is going to be 0, but then 15% of 1,000 is $15. So it's going to take 0 plus the $15, and that's the total tax you're going to owe. Let's say if you made $1,000. Now, if you made, let's say, $2,500, you're going to need to up this second level here, right? In which case you automatically owe $225 no matter how much you made between $1,500 and $3,000. But then you're supposed to take 16% of the excess. The excess is how much is over the $1,500 minimum limit. So if you made $2,500, you have to take $2,500 minus $1,500. That's $1,000. 16% of $1,000 is $16. So the amount of taxes that you would owe, right, would be $225 plus 16. Okay, and you basically need to do this for all of the salary ranges, right? So that's kind of the purpose of this checkpoint, is to make sure that you guys can implement this using pseudocode. So Appendix G is your requirements for this check. Next, in the syllabus, it tells you these are the things that it's looking for. It wants you to design a program that solves this problem. Generates a set of test input values so we can make sure to thoroughly test the program, and then perform a design walkthrough to verify your design. This design walkthrough is typically done via flowcharts, and so I'm going to show you guys what flowcharts are and how you would actually incorporate those into your Word document submission. And then finally, once you're done, you're going to post just like you always do. Okay. So let's pull up my example real quick, which is not the assignment, but it is very similar to the assignment. And so what I did was I thought, what is similar to this? And what I came up with off the top of my head is, let's just create a fast food ordering system program that is similar to your assignment, in that if you order more than $20 worth of burgers, you're going to get a 10% discount and a $5 service charge. If you order more than $50 worth of burgers, you get a $10 service charge and a 20% discount. If you order $100 worth, then you get a 30% discount and a $20 service charge. This is very similar to your Appendix G, in that you have kind of several levels of percentages that can be applied depending on what the total cost is, right? So I'm hoping everybody can kind of, and once we kind of go through this example, I think you guys will really appreciate how this can relate to your assignment. Okay, so first things first, what do we need? Well, let's look at the rubric. Let's look at the rubric real fast. Let's make sure that we cover everything that we need in this Word document. First, you want to design and include an IPO chart. And I know you guys have had a little bit of problems with the IPO charts in the past, and that's why I want to go over this now. The second thing is the walkthrough component. That's your flowchart diagrams. Again, I'm going to show you guys how to do that in this example. The design also includes the correct pseudocode in order to implement this. This pseudocode is how to implement pseudocode is described in your readings, but it's kind of all over the place. So I wanted to kind of show you guys how you would implement my example. That's not your assignment, but it's very similar. How you would implement that in pseudocode. So we're going to go over that, and then finally, this is also very important in the real world, and that's a table of test input values. That also needs to be within this assignment. So let's go over each one of these 4 components individually, and let's look at those. So the first component is your IPO chart, your input process output chart. So what you want to do with your IPO chart is you really want to kind of step back and look at this from a high level. Look at your requirements at a high level and kind of ask yourself, okay, what are the processes involved in creating a program that can meet these requirements? So I've kind of outlined the requirements for my fake example that is similar to your assignment, but is what we're going to implement, within this example. You guys don't need to implement this example, right? You guys are required to implement what's in Appendix G, okay? But in order to kind of show you guys how to do that, I'm going to use this fast food ordering system example, okay? So if we take a step back and we say, okay, what are the processes involved in this fast food ordering system? Well, basically we need to get the number of burgers that are ordered from the user, right? I mean, that's the first thing, the first process that needs to happen is we need to enter the number of burgers into the system. And right now I don't want you guys concerned when you first start creating the input process output chart. Just be concerned with the processes. Don't be concerned with the inputs and the outputs. Just completely leave those out. So the first process that's involved here is we want to get the number of burgers ordered, right? The second thing is, well, what do we do with the number of burgers? Well, we're going to take the number of burgers and we're going to calculate the total bill with it, right? That's the whole point why we're entering in the number of burgers, is so we can figure out how much the customer owes. Well, that's great. Okay, so what's the third process? What else do you need to do other than calculate the total bill? Well, you got to display it, right? Otherwise, the customer's going to have no idea how much they owe. The computer's going to know, but the customer's not going to know. So, again, kind of think of it at a high level. What is required to make this program work? And I basically came up with these 3 processes. And for your assignment, it's going to be very similar to this. You're not going to have more than three or 4 processes, and they're going to be very simplistic like this. Okay, now once you have processes listed, now I want you to go through and start thinking about the inputs and the outputs. Okay, so for the inputs, let's look at the first process. Get the number of burgers ordered. This is where I think your reading material gets a little confusing. The input and the output for this chart is basically the data that is needed for the process to take the input and produce the output. So for obtaining the number of burgers ordered, the input, there is no real data variable that is used for input to this process. It's just the keyboard. The keyboard is used to enter in a numeric value, and once that input is received, the output of that process is it just sticks that value into an output data variable that I'm calling num burgers. You guys can name these variables whatever you want, just make sure that whatever you call the variables for your inputs and outputs are very descriptive. So when a software engineer comes through and looks at your program and he sees numburgers, a light bulb is going to go off and say, oh, hey, well, that must mean that's the number of burgers, right? So make a descriptive variable name. And then the second thing that's very important with your inputs and your outputs is what is the data type associated with that variable. Computers must always know anytime you have a variable in your program, what type of variable is it? Is it an integer? Is it a float? Is it a string? All of these variable types are described in your reading. But since we're using number of burgers here, that is basically a whole number, right? You can't order a half a burger. You can only order whole burgers. So in this case, I'm just going to use an integer, or I think your book says real, in order to store the number of burgers. Okay, so that's kind of how I got the input and output for the first process. Okay, so if there's no real data types used, just kind of put something in parentheses describing what the input or what the output is. Okay, so for the second process, calculate the total bill. What inputs are needed in order to calculate the total bill? Well, there's just one big one, right? And that's basically the number. You need to know the number of burgers before you can calculate the total bill, because the number of burgers dictates how much the bill is going to be. So for the input for this process, I'm basically taking the output from the first process, numburgers, and making it the input to the second process. So once we get the number of burgers from the first process, we're going to pass it as input to the second process. And then what does that second process create? What's the output for that second process? Well, it's going to take that number of burgers and it's going to basically calculate your total cost. It's going to look and see how big that total cost is, apply the requirements listed above, and it's going to assign a value to the service charge, and it's going to assign a value to the discount using the rules, the requirements that are listed above here. Now, your rules are a little different. Your rules are in Appendix G, but you're going to have a couple different variables that you're going to need to keep track of for your assignment, similar to the service charge and discount. So keep that in mind. And now the third and final process is this displaying of the bill. This is the part where you need to display everything to the customer so he knows why the heck he's forking over all this money, right? These hamburgers cost $3.99. He's not just going to hand over $3.99 because the receipt says $3.99. So how can we properly display this bill? What do we need as input in order to display the bill? Well, in theory, you just need total cost. If you just wanted a receipt that showed the total cost and that was it, you could probably get away with just total cost as input here. However, I think the customers are going to get a little upset not knowing where that total cost came from, and so I decided to go ahead and include the number of burgers, the service charge, and a discount so that all four of these things can be shown when displaying the bill. So this is my input to the third process, to the display bill process. I'm going to show total cost, number of burgers, service charge, and discount. Now, what's the output for displaying the bill? Well, there's no real data types, there's no real data variables being used for output here. We're basically just outputting all this information to a screen or to a printer so that it can be printed out, and that's basically it. So for the output for this one, I guess you could list the same as the input. I just hate doing that. Okay, so there's no real output. This process doesn't really. The only output is it basically prints the stuff to either a piece of paper or the screen. Okay, well that's it for part one, and this basically kind of explained what the requirements are and how to put together the input process output chart. Watch the next part, and I will go over the flow charts and the pseudocode.